In this tutorial, I'm giving a sample problem on Newton's second law with kinematics. So for this problem, it says here, a crate with mass 34.0 kilograms initially at rest is acted on by a net horizontal force of 143 newtons. Letter A, what acceleration is produced? B, how far does the crate travel in 10.0 seconds? And for letter C, how fast is it moving at the end of 10.0 seconds? So that's quite a lot of required to find, but let's deal with them one by one. Let's start with letter A. What acceleration is produced? Let's write down the given. First, we have a crate and it's 34.0 kilograms for the mass. There's an applied force, which is also the net horizontal force acting on it, and it's 143 newtons. Then for the initial horizontal velocity, take note that this is 0 because it says here initially at rest. Just be careful because sometimes the given is not explicitly or directly stated, but the terms like initially at rest, for example, it indicates that the initial velocity is 0 meters per second. And then we are aware that there are vertical forces acting on this object. However, they are not our main concern, but just to complete the main diagram or the free body diagram, it should look like this. So obviously, well, the horizontal motion is what we are after. Now, for the required to find, we're going to solve for the acceleration along the x-axis because of these circumstances. And then for the solution, of course, the first thing that we will be thinking about is the Newton's second law because it relates acceleration with mass and force. So writing it down, it's just sigma F equals ma generally. Then we just add the subscript x just to be clearer that we're dealing with horizontal motion. And then we rewrite it like this. So basically, we just divide both sides of the equation by mass because by doing that, you can cancel mass on the right side of the equation, leaving you with acceleration along x. So our equation is acceleration along x equals sigma fx or net force along x over mass. Next, we know the fact that the sum of the forces along x is just equal to the applied force that we have written down in here. So we can write our Newton's second law equation into this. There's nothing bloody, I just want to rewrite it using the actual variable that we are given. So it will be applied force divided by mass. Now, substituting the given, we have the applied force and we also have the mass. Now, take note that a Newton is equivalent to kilogram meters per second squared. So, Newton is just a special name for the product of kilogram and meters per second squared. And then we can cancel kilograms now, as you can see there. So, the final unit for our final answer is meters per second squared. So the answer is 4.21 meters per second squared. If you do this in your calculator, the value is reasonable considering that the force is actually quite high. Now let's proceed to letter B. So it says here, how far does the crate travel in 10.0 seconds? So this is the part where we need to integrate kinematics because the variables like how far, and then the time is also given. Those are kinematic variables, okay? Now, updating our list of given and required to find, the acceleration along x, as we have solved earlier, is 4.21 meters per second squared. And then since we are in letter B already, we also have to take note that another given here is the time equals 10.0 seconds, okay? Now, for the required to find, we are now looking for the d sub x or horizontal displacement because it says here how far, blah, blah, blah. Now, for the solution, okay, so how do we deal with this? How do we know what equation to use for the kinematics? First thing you have to do, you look at your inventory of given. So these are just Newton's second law variables, but for the kinematics, we have that VV. I call this that VV. So displacement, acceleration, time, initial and final velocities. It says that VV if you read it downward. That's how I make my students remember this. So initial horizontal velocity is known, and then we know the time, right? We also know acceleration, and then the displacement is what we are solving for. Now, if you look at this, you'll actually notice that the final horizontal velocity is the only one that is not known in the problem, and we're also not solving for it. Therefore, we call the final horizontal velocity the missing variable. Again, when you say missing variable, it is the variable that you don't know in the problem or you don't know its value in the problem, but it's also not the one that you are looking for at that particular time. And the reason why you need to be aware of the missing variable is because you have to pick an equation which does not contain that missing variable. Okay, so looking at our list of kinematic equations for assuming constant acceleration, you have to pick this equation because again, pick the equation which does not contain the missing variable which is final horizontal velocity. Okay, so as you can see, you don't see the final horizontal velocity there, so it's perfect for this problem. Now let's write it down. So that's our chosen equation. Let's clean the board first. And then the next thing we're going to do is that we have to cancel v naught x squared because the initial horizontal velocity is 0. So we can simplify the equation into d sub x equals acceleration times squared over 2. Then substituting the given, this is our acceleration, this is time, raised to the second power over 2. Now be careful with this. Some students, I remember some of my students would make a mistake here because they would plug in everything straight in the calculator and they would do 4.21, 10 raised, and then 10 raised to 2. Like sometimes they would include acceleration in the exponent 2, but the thing is that you're only raising time to the second power but not the acceleration. So it has to be time or 10 raised to 2, and then after that, you multiply the answer to 4.21 or to the acceleration, okay? Then divide the answer by 2. That's it. So you can cancel s squared in here. You will be left with meter as your unit. So the final answer for horizontal displacement is 211 meters, which is reasonable considering how far the crate has been pushed. So that's 10.0 seconds. Okay, now let's proceed to letter C. So how fast is it moving at the end of 10.0 seconds? So obviously, how fast it is moving after 10.0 seconds is referring to final horizontal velocity. Okay, so again, the d sub x has been identified to be 211 meters. Now, for the solution, again, our required to find this time is our final horizontal velocity. So, because we know d sub x and we know acceleration along x, then we also know time. We also know initial horizontal velocity. We can actually use any equation as long as it contains the final horizontal velocity, which is our required to find, okay? So these are our equations. We can actually use the first one because you can see the required to find is here. And it's also good to use it because the missing variable is displacement. And honestly, I prefer using an equation which does not contain something that I only solve for because there are some errors associated with it or it may be wrong or something, right? So yeah, it's the best equation to use, the first one. Let's clean the board. So that's our chosen equation. Now, we can cancel initial horizontal velocity because it is 0. So it can be reduced or simplified to v sub x equals a sub x times time. We plug in the given. This is acceleration, 4.21 meters per second squared. And then time is 10 seconds. Now, you can do s over s squared because it will leave you behind with s on the denominator. And the final unit for velocity would be meters per second. So the final answer is 42.1 meters per second. Take note, it's pretty fast, which makes sense because our assumption is that this horizontal force is constantly applied. But in reality, it's not supposed to reach this high velocity because in pushing something that's really heavy, we normally just exert a very high amount of force at the start when we are transitioning and when we are trying to make the object move from being in a state of rest. But once you've set something in motion, it's actually easy to keep it moving because kinetic friction is easier to overcome compared to static friction. Anyway, this is the general guide for problem solving on Newton's second law with kinematics. You may copy this or take a screenshot. And that's all for this video. Thank you so much for watching and have a great day.